scripts and particle effects, all sorts of information about the way the environment works, as well as the 3D models that you create and the actual 3D content. So with that OR converter, we've already got an externalized resource. So it's largely an XML set of XML files and flattened methods for all the 3D models, in order that you can bring them out, put them into a big zip file. It's a tar.gzip file formally, and that file that can then be used for various purposes. So that becomes the input to the tool I'm going to be talking about today. And in particular, this tool was created to create the Collada, the .dae type files that are used in Unity 3D, in order that we could use Unity as a further development environment, but using OpenSim content in Unity to take it and reposition it and reuse it elsewhere. As I mentioned, that software was developed by Fumikazu Iseki. Now, his avatar name is FumiHax. So if you see FumiHax in Second Life or OpenSim, that is Fumikazu Iseki. This converter can run in Linux and on Windows. Source code was made available, and when I first used it, you had to really have a lot of permissions to be able to use it in Linux and to be able to set it up. And it was really more of a Linux tool that happened to work in Windows if you got all the setup right. But it was still pretty technical. But for convenience, after Fumi and myself spoke about this quite a bit, Fumi created a Windows UI that makes available the tool in a ready-to-run package. And what I'm going to be talking about today is mostly that Windows tool. The tool itself is pretty straightforward. We're talking about the route, I should say, the workflow is pretty straightforward. We're going to go from OpenSim to an OR file, so you use save OR, the save OR console command, to be able to save a region. Once you've got that OR file, you're going to run the OR converter in two pieces, and I'm going to explain that a little bit more in detail. But you're basically loading in the OR file and then creating the output Collada DAE type file. That is then going to be input to Unity, but it's going to be done through a specially written shader, as it's called. A shader is a way of modifying content as it's brought into Unity or as it's displayed. And a specialized shader has been written to take the types of files created and bring them into Unity for processing. And I'll explain more about that process in a second. The tool itself, when it's running, is pretty straightforward. This is the Windows UI version is what I'm describing. Basically, you're going to go into the file menu, open the OR file, and then once you open it, it's going to place it all into a directory that basically unpacks that OR file in a way that can be used within the OR converter. And then you're going to make the conversion. Now, there's many parameters and settings that you can use to adjust the way it works. There's all sorts of options in the tool for viewing parts of the 3D model and even producing things like STL files, which you can use for 3D printing elements of what you've brought out from OpenSim. So this is a pretty flexible tool. It's got lots of different capabilities. You can do all sorts of X, Y, and Z shifts of the content as well. A lot of that you'll find when we're just using Unity isn't needed, but this could be useful for other people or wanting to use this material in different environments. So that's what the interface looks like. And then this is a bit of a dense slide I'm looking at now, but it's some notes on a quick start of how this works. And I'll just quickly go through it because it gives you a feeling for how this would work. And remember I said this quick start and some of the other notes I'm providing here is on the blog page that I'm going to summarize at the end, the web page you can use. So first of all, you're going to place your OpenSim OR file in a directory somewhere. And using the defaults, if you just load that OR file and do the conversion, you'll find that your OR unpacked and the converted Collada DAE files are in that same directory where your OR was placed, just with prefixes OR underbar and DAE underbar. So once we've got that OR file read in and we've got our OR underbar unpacked material, you just select the file menu again and then say convert data, and it's going to convert the whole thing. It runs pretty quick, but it may take a couple of minutes if you've got tens of thousands of objects, but that's going to then create your DAE underbar with a name, and your converted content will be in that. And all the Collada objects, all of the textures that are needed for this are all going to be in that area. And in particular, it separates the solid objects in the region that you've converted from the phantom objects. So we're going to have solid and phantom objects separated, and that's going to be interesting and useful later on when we import it into Unity. The import to Unity is also pretty straightforward. The important thing is to make sure that you use a special shader that's made available in Unity before you take any content in. So anybody who's talked to me about this tool, if they've forgotten to do that, that's usually where they get basically a bit of a mess as things come in. The textures will all be wrong. And the shader is included in the OR converter, in the OR converter distribution, but you've got to put it into an area that starts with in Unity with a file name that starts editor. It can actually be at any level where an editor appears, but typically editor is at the top level of your Unity project. So as long as you put this specialized shader, the name of it is select or shader.cs. So it's a C# script, and once you put that into that editor, you can then start importing your material. You can actually just literally drag and drop the whole of the Collada, both the solid Collada file, DAE files, and the Phantom ones. You can literally just drop them into the project and it will all be there and you can make use of it. But I find it's more convenient to make yourself an empty game object, an empty Unity game object at the location 000 and put that into your project before you start. And then you can drag and drop into that. And it's useful later on because you can then move entire regions about, especially if you want to compose a Unity scene with multiple OpenSim regions. I'll give you an example of that later on that we've made use of. I use that quite a bit these days. But basically, once you've got this empty game object, I typically place my solid OpenSim converted objects into one subdirectory of that, and my phantoms into another one. That lets me then manipulate those separately if I want to. All you then do is literally drag and drop the entire DAE folder onto that area, dropping it, in my case, onto that empty game object, and within a minute or two, all of that will then appear in your project pretty much instantly. The idea in the terrain is brought across. As you'll see in a minute, it breaks it up into a number of parts because of the limitations in Unity on 64,000 triangles, polygons in any object that comes in, and the terrain tends to be a bit bigger than that. But except for breaking that up into parts, the terrain and the objects will all be brought across. The water layer is not brought across. So typically what you do is add a water layer also at 000 using standard Unity assets. And pretty much that's it. But there are a few issues that may arise. So first of all, you should take care that you do have that select or shader.cs file, the specialized shader that I mentioned. You should make sure that that's in before you start. If you see anything wrong, it's best to go back, start again, having put that in. You'll get a warning for the terrain being imported, except for the most simplified kinds of terrains. Typically, the terrain will be broken up into multiple 64K areas. Typically, you'll get 3 areas. But that's not a problem. They all lay alongside one another, and you can even adjust them all separately if you need to. Now, during OR conversion, you may have seen a number of errors being reported on texture conversions. I find most of these don't cause any visual issues, but it's because OR converter is trying a number of different JPEG 2K library converters, and some still can't be converted, even with all of the options that Fumia's Echo tries. So it tries a number, watching for failures, and tries as many as needed until it gets success. And in some 1 or 2 cases, you still can go through all of those different JPEG 2 conversion libraries and find that they don't convert. I see sometimes when I'm starting up my OpenSim regions some of these JPEG 2 conversion, JPEG 2 texture issues. So it is just because we've got so many variants, I think, of JPEG 2 in a lot of the various versions we've used over the years. Now, bearing in mind, though, that OpenSim, the OR converter, doesn't bring across any active scripting, particle systems for smoke and fire and so on, or very specialized light sources. You need to add these again into your project. But it's pretty good at bringing across most texture visual effects and preserving those. It does use legacy Unity shaders, and that can be a little bit of an issue if you're going into certain environments, and you can convert that later on by looking at those legacy textures and converting them to a standard Unity texture. But the legacy textures is what's used in the current version of the system. I'm just going to show you an image of a Unity. I'm just going to show you an image of a Unity editor with a converted region already brought across, just to give you an idea of what this looks like in the Unity editor. But there's nothing fancy about it. It's basically just all the little parts that have come from the converter dropped in. The first conversions that were done and that we tested. The first conversions that were done and that we tested the OR converter on was the buildings that we've got in our OpenSim areas for the Tokyo University Information Sciences group. They have their building, and the picture I'm showing is of the conversion with OpenSim on the left and the Unity version after conversion on the right. And the top one is the Tokyo University Information Sciences Institute, and the bottom one is the open virtual collaboration environment in OpenSim, and then converted to the right. And if you can see those images, and if you can't, look at the web page later, you'll see there's a pretty direct comparison between the conversions. You don't lose much on the 3D conversions at all. It brings across the trees, the foliage, and everything like that as well. You can actually, in the Unity editor, immediately visit the OR converted region just by using one of the third-person controllers. If you use a standard Unity Ethan asset, for instance, you can literally walk straight into that environment. But the OR converter also includes a free Unity Japan character, like an anime-style character called Unity Chan. So you can pick that up if you want. But the Ethan one or any other third-party, any other third-person controller you use works fine. And you can just walk into that area and make a look at it before you even produce it. So I'm showing a picture of just the Ethan Unity character. Now you can walk around, check it's all working, check the collisions work as you expect with walls and things of that kind. During the testing and the work I did working with Fumi, we did a lot of conversions of some quite large areas. Some of these OpenSim regions that we tested had anything up to 10,000 primitives in them, or mesh and existing Collada mesh content in them. So OpenVC I mentioned, the Tokyo Institute I mentioned, but I also have some science fiction areas with Jerry Anderson style science fiction areas, and an oil rig that's from Robert Gordon's University up in Aberdeen, which is quite a complex build. There's the castle there and Edinburgh region. So quite a lot we use for testing and for refining it. We had some problems initially with things like some of the plants and so on didn't look quite like they did, and a lot of that was then tidied up during testing and testing the tool. One thing you may be interested in is a particular use of this tool then with an existing MMO, one of the MMOs that's arriving. Adam Frisby last night, who was one of the original OpenSim developers, was talking about ScienceSpace last night, which is an MMO that uses Unity as its build environment, but then provides a massive open online environment with multiple regions that people can then enter into. And we've converted quite a lot of OpenSim content through to Unity and then published it into ScienceSpace. In fact, Adam Frisby has done some work to make this process a little bit more efficient. One of the problems with OR Converter is that it's a little bit profligate with its use of textures because of the way it tries to encode information about the other visual properties of textures on particular prims. For instance, the glows and the shininess and other properties of that kind. It tends to use more materials than it really needs to in describing all the various textures that go on to and material properties that go on to the converted objects. So what Adam's done is provide, within the Unity editor, he's provided a tidy up tool, which you can find in one of the menus that's added by the science-based development tools inside Unity. So ScienceBase adds these menu entries, and one of them is to do an all material cleanup, and it can significantly reduce the number of repeated textures without causing any visual degradation at all. And in particular, we've brought across 12 of our regions from the Virtual University of Edinburgh, which appear in an OpenSim build on our OpenView grid. We brought the 12 regions all across, all as separate 256 by 256 grids. This is not one mega region. It's just a number of regions. That's the way we've continued to use it. And we've brought them all across separately, put them into these empty game objects I mentioned at 0, 0, 0 initially, and then simply shifted them all by 256 meters in an X and a Y direction, and that's let us lay out the whole 12 region grid, and then simply publish it out to OpenSim. And I'm showing a picture here of the open virtual collaboration environment with a couple of ScienceBase test avatars, and so you can immediately see that you can just go into ScienceBase, enter that region, and you've immediately got voice and social elements where you can interact together in the environment. The build as it looks as you enter ScienceBase, you can see the 256 tiles still in that image I've used, but that's the Virtual University of Edinburgh's OpenView grid with an open virtual collaboration environment and various portals, all put onto ScienceBase using ORConverter from OpenSim to Unity to ScienceBase. You can, as many of you probably know, you can use Control, the Control Alt Studio Firestorm-based viewer to look at OpenSim content. Although, as Frank mentioned earlier on in one of his talks in this conference, you can't really get the frame rates for that. But ScienceBase is actually implementing virtual reality viewers and Oculus viewers that can be used in ScienceBase. So this is another way that you can use virtual reality to see this content when it's being converted and brought across. The license itself has been made as flexible as you can imagine. It lets you do anything you like with the tool, so long as you don't use the names of those who created it or the name of ORConverter to promote or endorse your own products. Other than that, it's a very flexible license that lets you pretty much do anything you like with it. There is a web page. As I promised, there is a web page. The web page is blog.inf.ed.uk/88/OAR-CONV/. So basically you can find that, I'm sure, by using web search as well. But that page will give you all of the links to the downloads and other information, and also give you some of this quick start information that I've been discussing. So hope you found that talk useful. Thank you.
And thank you, Austin. We did have a couple questions come up. Let me go back here and see. Grimisa says, can DEA step be brought to Blender directly?
Not directly. So one of the problems with Unity Collada import is that it takes a slightly different, it's almost like an illegal version of Collada. So Fumi, when he did the tool, made sure that he produced Collada that could be imported into Unity. Fumi himself is very aware that there's a number of things that could be done to expand the tool and make it more useful for a number of people, users, including import to Blender, and indeed FBX export, which some of us have been starting to get interested in because of FBX being a potentially, although it's a proprietary format from Autodesk, it is being used in a number of new environments like High Fidelity and Sansa now. So you can imagine that we're interested in a route. I'm going to put up a further slide. This is it's a development path that we're using at Edinburgh for some of the experiments and moving about between these tools. And there are different things you could do. For instance, from Unity, there's a new FBX exporter tool. And I've done a little bit of experimentation with that, but not a lot. And it could be that could be a route by which once Collada is inside Unity, you can get FBX out, which might give a route to Blender. But there isn't a direct route to Blender right now because the Collada will be treated as illegal. A lot will import, but not all of it.
Okay. And Austin, will you be at a booth for a little bit for further questions?
Yep. Yeah, I'll go over there after we've just given this this talk and hang about. So, the booth is number 5. So if any of you are interested in just chatting, but if you can also email me or IM me as my avatar if I don't happen to be online. I will be coming back later on for the Hypergrid Safari because we're visiting one of the OS Grid regions that we run during Thursday's Hypergrid Safari. So, but you can find me around or email me. The contact points were on that previous slide.
Okay, well, thank you very much for joining us. It was really interesting, and I think a lot of people are going to be trying this out. Okay, our next session will begin at
You're welcome. Thank you.
And is entitled. Okay, our next session will begin at 8 a.m. and is entitled Creating Case Study Educational Simulations for In and Out of World Use.